mainly what I want to do today is introduce myself, what this course is going to be about, maybe talk you into dropping the course if it's not something that you actually want to take. It's a pretty cool course, and it's really easy to succeed in this course if you do all of the work. There is a fair amount of work for it, and so I do want to dissuade you if you're not interested in it. The other thing is that this is a class where twice a week we get together and talk, and I really want it to be a discussion course. I have done this for 4 years now, and I'm really tired of just talking to people and just having this be a one-way thing. So to that end, it would be a much more fun time if you guys would actually sit in the front up here. There's only 20 or 30 of us here. I'm not going to make you get up right now unless you're feeling brave and courageous, but it would be really nice if we could have this actually be a discussion. To that effect, a reasonable piece of your grade is going to concern participating and attending and being here every week. If that's not something that you like, maybe don't take the class. That's just the way I want to do it. There's no exam in this course, which is pretty cool. And so in order to actually make sure that you guys are hanging with me as I go through this material, I need to be able to talk to you. And I also, I really get a lot out of hearing from you guys and hearing how you guys are experiencing the world that we're living in. Despite the fact this course is about the stuff above our head at night, it's also largely about how we have related to that business throughout the course of human history. So we're going to be looking a lot at how ancient people saw the stars, looking at a lot about the cultural implications, the way we see the stars, the stories that we tell in the liner notes between everything. How many people here have ever even heard of astronomy? How many people, do you guys even know what the word astronomy means at least? How many? I mean, don't be embarrassed. It's totally fine if you know nothing. I don't expect you to know anything whatsoever. I'm just kind of curious. Anybody interested in the stars, telescopes? Let's get a show of hands, people who are vaguely interested in the stars prior to this class. Okay, cool. So of those people, do you guys every once in a while read headlines or follow any kind of I don't know what social media you guys do, but you kind of pay attention to what's happening in terms of what people are learning? Show of hands, maybe? Okay, all right, awesome. So the fun part about this course then for those people is that the stuff that you're hearing about out in the world about the stories that we tell about the stars, that's only going to be half of this course. There's actually a whole substratum of argumentation against a lot of those ideas, and we're going to be dealing with that head on too. I really think that we've entered into a really, really interesting age right now, one where information has never been easier to get a hold of. You guys use AI, ChatGPT, stuff like that? No? Show of hands? Who's used ChatGPT today? I did. Who's used it in the last week? Or something like that, Grok or Gemini in the last week? Not too much. Okay. I'm honestly a bit surprised by that, but then again, maybe not. It was really funny. Before the semester started, they sent these little bulletins out to all the faculty, and they say, AI is changing everything. We want to put a statement in the syllabus to tell your students how you feel about AI. And it was funny because they drafted 4 different versions of it. The first one was ChatGPT is the devil, absolutely don't touch it. You can't use it in this classroom whatsoever. And then there was 3 degrees of that, and then the final degree was ChatGPT is wonderful, you should absolutely use it, you have to use it for this course. And I think that's actually really profound. It really speaks to how confusing this moment is, because when I went to college, which was a million years ago, they just tested you on the knowledge, right? You read the textbook, you learn it, and then you spit it up, and that was it. But that's not the future, right? You can go and look any of the stuff up that we're going to talk about in this class. If you forget it, you think about it 2 years from now, you can go look it up really fast. You can just ask one of these AIs to look it up for you. You can go type it into Wikipedia. There's a million places you can get all this information. I mean, the textbook we're using is an online textbook. It updates regularly. I've been in the middle of pulling pieces of it, and it changed in the middle of it, right? It's state of the art. The knowledge is there. The question is, how do we deal with it? How do we compare the knowledge that exists to the knowledge that we can't see? And when we find pieces that don't jive with each other, what do we do? And so that's kind of what this course is really going to be about. It's going to be about comparing ideas. And if you guys do decide to stick with it, and you don't drop the class, the whole thing is going to culminate in a project where you're actually going to compare one idea, a theory of some, well, we'll not get into it. You're going to compare one theory with another theory about the same idea. And it's going to relate, obviously, to the solar system, since that's what the first semester is all about. So, and I'm going to show you guys how to do that, because I'm going to be doing it constantly as we go through these things. You know, the textbook has a very, very narrow story about every single one of the planets and bodies we're going to talk about. You know, this planet was formed here in this year, you know, billions of years ago, and this is how it went. Well, why do people think that is really what we're going to be asking. Why have they reached these conclusions? Are those conclusions combated by other ideas that actually, you know, maybe shed some light on the fact they contradict themselves? Are there other stories for how these planets could have formed? And it turns out that, yeah, that's what happens in science. There's a story that makes it to the headlines, and there is a sea of argumentation below the surface in almost every single topic. And that's what it's all about for me. And so I think what's really cool is that all the AI in the world is not going to help you out with comparing ideas. The AI is perfectly capable of going out and finding what the most popular idea is and telling you it as if it's a fact or something. But it's not going to be able to actually like get down into the argumentative layers, right? It's not going to be able to actually understand what people are fighting about at conferences. And that's something I really want you guys to understand, because science is a really cool exercise at its foundational level for pitting ideas against one another and seeing what comes out on top. And ultimately, that's something that I don't think that AIs will ever be able to do, which means that if you want to guarantee your job safety in the future, you could probably go become a plumber or something. But you could also learn how to think really well, because AIs don't think at all. They just regurgitate what they have found to be evidenced in the body of knowledge that we have. And so some part of this is going to be about surveying the knowledge. You guys have a textbook. You're going to have these really easy, short little quizzes that should take you 15 minutes every week to go through, just to make sure that you understand the standard narrative, because I'm not going to be spending a lot of time on it in class. So I want you to be on the same page about that. So you have a little bit of that. You're also going to be doing these really short 2-minute video exercises every week. I basically ask you to go in, check out the watch list or the reading list that we have. I'm going to put up all sorts of videos and papers, weird stuff that you're not going to find in the textbook. And I want you to kind of synthesize some of those ideas. So the first week is super simple. I just want you to introduce yourself to me. I'm also going and to your classmates too, because we'll kind of be checking out each other's videos from time to time. So that forms the bedrock of the lecture side of this course, which is a huge part of it. There's also a workshop. So there is a virtual astronomy observatory. Right? We obviously don't have an observatory here at SOU, unfortunately, but it's a pretty cool piece of software. It only costs $30. You can download it, and there's some exercises. And honestly, it's a good complement to the discussion we're going to be generating, because at the end of the day, this is the way, this observatory, this virtual workshop is going to walk you through how it is that people have made the measurements that result in the evidence for the conclusions that they form and the theories that they make. And so we do need to understand a bit how that data comes to be. So those are the main pieces of the class. That's how you're going to be evaluated. What I'm going to do is, concerning this discussion, obviously we're not discussing much yet, so I haven't really put anything on the table, although I do have some questions for you guys. At the beginning of each class, when you guys come in, like I said, please sit closer than further. It's my eyesight's not what it used to be, so if you're in the back, it's harder for me to engage. But if you sit up front, we'll spend a bit of time at the beginning of each class sort of checking in on what happened last class. So if you need to miss a class, that's totally cool. I put all of these lectures up on YouTube. You can watch them at 4x if you can think that fast. And I just ask that you send me a couple of deep thoughts, at least enough, get something out of it enough that you're going to be able to discuss stuff with us at the beginning of the next class. It's super simple. There is nothing difficult. Everybody can get an A in this class. I hope you all do. if you don't want to do the work, you won't even pass. And so there's no point in you just wasting your time and money. You should take something else. But if all that sounds cool to you, there's no reason that everybody won't walk out of here with an A. And hopefully, we'll have all learned how to think a little bit better. So that's the goal. Questions, concerns, terrors? Yes. Oh yeah, can you tell me your name, by the way, when you ask a question?
Yeah, my name is Ezra.
Ezra, good to meet you.
So actually, I noticed in the past this class had a lab to go with it.
Yep. So the lab's been wrapped in this year. That's the workshop virtual observatory that I was talking about. So it does count, this will count for your GE requirements for science with a lab. So that's pretty cool, I suppose. It's the first year we're doing that. I actually thought it would boost enrollment, but it just seems to have confused everybody. So, you know, what are you going to do? What else? All right. What else do I want to say here? Okay. I do want to make it into some material here. I want to make sure that I've gotten everything out of the basics. We need to talk about essentially what the subject matter is that we're going to be studying here today. And then maybe we can take a little tour of the solar system and the galaxy before we get out of here. So we'll talk about, I guess I should introduce myself too. I'll do that. We're going to talk about what astronomy actually is. Every single year, I get an email from a student who says, Dr. DeLay, I'm sorry I missed class. It's usually titled, Absence from Astrology class today, which I find very cute. This is not astrology class. There's a difference between astrology and astronomy. And I'll get your thoughts on that in just a second. So we'll talk about that. I want to talk a bit about what science actually is, because it's one of the most confused and, let's say, overly circuitous and ambiguous words, I think. We'll talk about science versus math, a bit about physical laws and stuff. All right, we'll get to that if we do. If not, we'll get to it next time. So let's go to astronomy really quick. Let's start with astrology, actually. So what's the difference between astrology and astronomy? Yeah, what's your name?
Dante.
Hey, Dante.
Basically, astronomy, as far as I know, is the study of space, the study of stars. Astrology is like constellations and the simply astrology is mostly voodoo. I don't know how else to put it.
Okay. Yeah. I'll buy that. What else? Yeah. What's your name? Hey, Cassidy. Yeah. Cass.
Astronomy is like scientific studies, the facts, astronomy or astrology,
Yeah, it happens to the best of us.
It's more like, I don't know, I wouldn't call it food-based, but it's not necessarily backed by science.
Anybody else? So there seems to be a dichotomy between science and astrology, which is interesting. Anybody? Yeah, what's your name?
I'm Ella.
Hey, Ella.
Astrology well, or like belief. Well, astronomy is a little bit more like evidence, at least, like focusing on science. I could be wrong.
Yeah, absolutely. I think that you guys are kind of pointing to it. I mean, yeah, I think that what's interesting is that it's actually a pretty difficult question, because astrology also in some sense is evidence-based, right? They'll say these are the stars in the night sky tonight. First of all, it's like, yeah, that's true. And they'll say like, this is the year you were born, and these are where the stars were when you were born and stuff. It's like, okay, maybe. And then the conclusions follow from that, right? The difference, I suppose, is that the conclusions are sort of stated in the case of astrology, whereas in the best case scenario in astronomy, the conclusions are rationalized from deduction, right? So you see something, it is a light in the sky. You see enough of these lights, you start to group them together like a stamp collector, and you find patterns in them. And then eventually you can apply what you understand about light from the laboratory to this light you're seeing in the sky, and you make some hopefully justified conclusions about it. Although, the conclusions are still theoretical at the end of the day. They're still pitted against other people's conclusions. And so, it's not so much one is more certain than the other. It's just that the process by which you deduce them is a little bit different. Astrology is kind of weird too, and I think we cover this later in the course a bit more. But another thing about astrology that's kind of bizarre to me is, it's supposed to be, it's this ancient system of divining, your fortune based on the position in which the stars were at the time you were born, which is actually a really interesting idea on its face. We'll explain why that's interesting as we get deeper into this course, mainly because, the environment actually does seem to dictate a lot of things at any given point in the universe, but we'll get to that later. The weird thing, one of the most weird things about it for me is that astrology assigns a birth sign to you. The problem was that system was made something like 2,000-ish years ago. Actually, the stars are in a new position in the sky now, so whatever you think your sign is actually not your sign. It's actually off by a month. So that's an interesting little feature too. But I'm kind of beating a dead horse here. So there's obviously two different approaches, and maybe you don't come back to the next class, but hopefully we'll go out into the world and not make the mistake of confusing astrology with astronomy, though they do have the same basis, which is astro. Do you guys know what the word astro means? What it's a root word? Yeah. Yeah.
I think it's stars.
Yeah, stars. Yeah. So it all starts with stars. And interestingly, stars as a concept is much bigger than what you guys probably think. So when people first started doing astronomy, really just, by the way, nomos, what does that mean? Astro is stars, yeah, so astronomos. Anybody? Nomos? Yeah. Close. It's like, the root word means something along the lines of laws, really. So it's actually making up some sort of patterns to what the stars are doing. Now, originally, the word star meant anything glowing in the night sky. So for most of history, people did not distinguish between planets and stars. The word planetos actually just means wandering stars, and we'll talk about why that is. But obviously, they're the only stars in the night sky that change their position from night to night, with any measurable distance on a daily basis. So they're the wandering stars. So yeah, so we're measuring the stars, we're making laws for them. Again, we're trying to deduce patterns. And then, very similarly to astrology, from those patterns we try to draw conclusions. That's where things get really mucky and interesting, actually. Okay, cool. So the interesting thing about astronomy as a science, I think, which is different from most every other science, is that astronomy terminates in a much bigger study, which is called cosmology. You guys ever heard of this before? What's cosmology?
Study of the cosmos.
What's the cosmos? Everything. That's pretty crazy, right? So the word cosmos, does anybody know what that means? It's a Greek word. What if I told you it's the opposite of the Greek word chaos?
Oh, right.
Right? So it means to order something, right? So that's pretty nuts that this is a science which, for whatever reason, and by the way, we'll debate whether this was a good idea or not, but for whatever reason, the scientists took on the art of cosmology somewhere around the 1960s. It hasn't been very long, actually. It's actually one of the youngest sciences. I think maybe neuroscience is a bit younger. But cosmology used to be the domain of who? Anybody? Who was, yeah, what's your name?
Isaac.
Isaac, hey.
Would it be like philosophers?
Yeah, philosophers. And what about before there was philosophers? It was the church, basically, right? So the stories that you tell about everything, the universe, what is it doing here? Why is there something instead of nothing? What the heck is going on? We're a bunch of atoms that are all talking to each other and having Zoom meetings and this is insane. That used to be a metaphysical discipline for most of history. Now, even once there was the academy, it was still, they gave that to the theologists, the divinity school. Yes, there was some philosophers concerned with it. We'll talk about them a little. You got a question? Yeah?
No.
Oh, okay. Comment? Go for it.
Nowadays, scholarship and religion are often very seen as antithetical to one another. But not that long ago, and for most of human history, they were one and the same.
Exactly. In fact, the birth of scholarship was really in medieval Europe with the monasteries. That's where people first started actually cataloging books and digging up these ancient transcriptions and really putting them together.
As a Jew with the synagogues, if you ever go to a large one, they're basically libraries.
Yeah,
That's their main purpose.
absolutely.
Purpose.
Absolutely.
You go to the same, they're the same, for the same reasons you would go to a library today.
Absolutely.
The same community, the same little study spaces, little tables for people to read.
Yeah. Yeah, so it's interesting. So science, so the really, I think this is like the point I'm trying to get across is that by studying the stars, which is an absolutely, like on its face, cataloging patterns in the stars, entirely empirical, it seems very objective practice. But the conclusions that are drawn from what we see in the sky are literally applied to our modern metaphysics. Does anybody know what the hell that word means, metaphysics? What am I on about with this metaphysics stuff? You ever heard that? Yeah.
Like breaking apart.
Yeah, that's not a bad interpretation. Meta meaning above or beyond, perhaps. I think it's generally used in the sense of beyond physics. So it's sort of like your rule pattern for how you assess what you see. So, you know, if you're a religious person, let's say you're a religious person, you have a belief in some particular God. Well, the way in which you view everything that happens to you is going to be filtered through the lens of that metaphysical belief, right? Now, even if you're not a religious person, it doesn't matter. Like, you still have a metaphysics. And your metaphysics might be that science explains everything. Well, does it? Can it? Is it actually up to the job? I think that by assigning cosmology to the scientists, we've, as a society, kind of, well, I don't know if society agreed to that so much, but it did happen, and it is the case that scientists do house a department at many universities called the cosmology department. So people do view the cosmology through this metaphysical lens that science is capable of explaining everything. I think that as we work our way through this course, probably more next semester, but to some extent, we're going to really examine the basis of that claim. Is science really cut out to the study of everything? I, for one, don't think that it is, but that's an interesting piece of the puzzle that we're working with here, because all of the conclusions that are being set forth are in some sense metaphysically bound. They actually orient us as a civilization and a people towards who we are. Many times the conclusions we draw, whether it's that the universe hatched out of something smaller than a point of dust and will end in a giant heat death, that's a metaphysical conclusion. That really orients us towards who we are and where we're going, right? So these things matter in a weird way. The basic science of astronomy is applied in an enormous capacity in a way that I think in some sense shapes and reflects who we are as a people and as a civilization. And we'll see how this plays out as we get deeper into it. But in many ways, I think a lot of the big bounded conclusions that are made from a lot of this data perhaps reflect more about us than they do about the universe, which is really quite interesting. Okay, so a lot of that, we really don't do cosmology too much until next semester, but I did want to just tell you guys that this is part of a bigger project, which is in some sense an experiment. You know, you mentioned, it's Dante, is that it? Yeah. That people generally used to view scholarship and religion as synonymous, and this is very true. I think that there's been a lot of dissatisfaction in modern times with science's inability to explain some of the more mysterious and profound pieces of the world. And in some sense, I think that the 20th century was this story of people, of kind of disenchanting reality. You know, it's like, it's all just, atoms doing their thing, grinding into each other, whatever. But I think that's been really dissatisfying for people, and it's increasingly dissatisfying. And I think in some sense that we are going to witness a re-enchantment of the world. The question is, how does that unfold, right? Does it unfold in some sort of like terrorizing religious theocracy, or does it unfold in such a way that some of these basic approaches to reality are handed back to the humanities and really not assigned to the sciences that are incapable of dealing with them? this will all make a lot of sense as we move through this material. All right, that was a lot. Questions, concerns? Anybody uncomfortable, worried? What's your name, man?
Brendan.
Brendan. You look a little nervous. Don't worry. It's going to be all right. We'll figure it out. I don't have all the answers, but I am going to try to work them out with you guys. Dante.
What you talked about just now reminded me about the rise of nihilism in the 80s.
Absolutely.
Just because of the, not the discovery of atoms, but the widespread knowledge of them led to this idea that nothing matters.
Yeah,
What's the point?
absolutely. I mean, if the universe ends in a heat death, it's pretty hard to feel like your life is meaningful in some sense.
And what's funny about that is that led to a rise in zealotry, I will say.
That's what I'm talking about, yeah.
And that led to, again, a return more to science and empirical fact. And it's just like this cycle we've got ourselves into.
Yeah, absolutely.
Growing dissatisfied with religion, not explaining everything, going to science, getting dissatisfied with science, not being able to explain anything, going back to religion.
Absolutely. You could think of it as a pendulum in some sense, right? It's like this kind of swinging between these extremes in some sense. The question really for our generation, your generation, is really how to integrate those properly, how to approach reality in a rational sense, but perhaps recognize at the same time that there's more happening here than a bunch of atoms doing their thing. This is a really, really complex system of atoms that's going on here. There's layers of abstraction. So like when you design any of you guys have family members or anybody who are like work in the computer industry, code, or do build computers or anything like that? Okay, a few of you guys, right? So, if you're a coder, a lot of my family works in that industry, you don't have to know anything about how the computer actually does what it does, right? I mean, you don't have to know like what the atoms are doing to each other in the different layers inside of the CPU, right? You might have to know one level lower of abstraction, like maybe how that chip is organized in such a way that its logic gates are checked in parallel in some way so that if you do one process, it's going to affect another. Okay, but you don't have to know like how those logic gates are organized on the chip inside of your computer. Likewise, the guys who are down there actually figuring out the materials, figuring out how to actually make these chips move faster and do their thing, they don't have any concern for what that coder is doing up at the top, right? So there's different layers of abstraction. We are stuck with the same problem in our analysis of the universe, right? So science is really, really good. We'll see. It's really good at making observations and deducing the mechanics, the mechanism, so what those atoms are doing to each other. Really good at that. But in terms of when we move into these higher and higher abstraction layers, when we start to get into the actual coding of the system, right? The motivational structures, like what makes me actually want to come here and teach this to you guys, despite the fact they're paying me almost nothing to do it. Like, why would I do that? Well, it's a very complex series of motivational structures. We could say there's cultural reasons as well, but like, what the heck is a culture? It's a really high level of abstraction. And so there might be better ways at understanding and studying these things outside of just atoms and physics and chemistry and these sorts of things. So that's really interesting. This will all begin to make more sense once we start looking at some individual stories. And so the basic way this course, by the way, is going to be laid out is once we get some basic terms on the table, once we understand what astronomy is, for instance, and cosmology, and what science is, and all of this, we're going to basically take a tour of the solar system. So we're going to start outside of the sun. Unfortunately, the sun is my favorite topic, but all of next semester is the sun pretty much, most of next semester. So we're saving that. We're going to start at the interior planets, and we're going to work our way out. And we're going to try to understand what the heck those things are and why they're doing what they're doing, why they look the way they look, what people think, what people are completely tied up and confused about. So we're going to be basically making a tour. And so each one of these is going to give us a chance to think about how the ancient people saw it, the stories that they told, how those stories reflected those higher abstraction layers, right? It's going to become really interesting and apparent that the people who told these pretty far out superstitious stories about the planets and stars, they weren't superstitious idiots, actually. They were encoding a tremendous amount of abstract knowledge in those stories. And so we have a tendency to look back. This is just something humans do all the time for some reason. Whenever we look back in time, we always think that the people who came before us were kind of stupider than we are, which is, I think, a terrible mistake, because however you want to cut it, we've basically been human beings for, you know, 1 million years or so. That's a long time to be stupid and still survive, right? We've actually figured out a lot of things about how we worked long before we knew anything about atoms. Yeah, what you got?
That reminds me about the all of the pseudoscience I've seen a lot of people talking about, with like how people in my generation somehow have a hard time understanding how the Egyptians built the pyramids without modern technology.
Yeah, I hear that one a lot.
And it's not that the Egyptians were dumb, it's that you are. It's that you're not, or you're just, you aren't able to, you don't know enough to that, like nowhere near what the people who built the pyramids.
Well, you probably don't think about the world the way they did. You probably wouldn't go about building a pyramid the same way. I actually have a friend who wants to build a pyramid. He's a multimillionaire, and he doesn't know what to do with his money. He's like, I'm going to build a pyramid. I'm like, all right, man. Yeah, I think he would go about it completely differently. I have a lot of thoughts about the pyramids. We can talk about that at some point. We'll get back to it. But I agree with you. Like, it's very hard to understand how people without cell phones could have been extremely intelligent and really insightful about their world. And I think we fall into that trap a lot. You know, again, just because the Egyptians didn't have you know, neutron beams and Zoom chats and things like this, they weren't dum-dums, for sure. And the stories they were telling were actually really serviceable, and they allowed that. I mean, the extent to which the Egyptian empire persisted is incredible. You know, our empire in the West here, let's say this modern revision of this social democracy experiment, whatever it is, this democratic republic, 300 years or something for the United States. And it's like kind of in bad shape right now, right? There's serious questions about the future in our country. I mean, the Egyptian dynasties went on for thousands of years. Like they had a really, really solid way of encoding their understanding of the universe in such a way that it could be transmitted serviceably from one person to the next, and really gave the people some sense of solid ground to dig into. So, you know, when we start talking about like these cosmological stories that our astronomy points to, we have to actually start asking ourselves if they're serviceable. Like, are they actually reflective of the world we're living in, and do they actually give us anything to bite our teeth into? So anyways, this will all make sense. We're going to go through each one of these bodies. We're going to look at the stories that people told. We're going to look at the stories people are telling now, and we're going to see if those make any sense. Some of them make more sense than others. I will preview that reality for you. There's a lot of questions, and we have a lot of pride as human beings. One of the weird things about scientists, by the way, before we even talk about what science is, one of the weirdest things about scientists is that, well, let me ask you guys, why do scientists work? Like, why would you ever be a scientist? Yeah.
They're really curious.
Right, that's about it, pretty much. And how do you get paid as a scientist?
Do you get enough research?
Well, yeah. Research, you get grants maybe for research, yeah. But, you know, I'm going to come back to this. I think we need to define what science is. Most people confuse it terribly with engineering and technology and stuff like that. So how about, let me just ask you this. What's the difference between science and engineering? And which one do you think makes more money? Absolutely. So what's the difference? You guys intuitively grasp it. I'm going to give somebody else a chance. Anybody?
I was
Okay. I can never tell. You've got the posture of just ready to go at all times. You're like the guy on Jeopardy who's just like, yeah, over here. What's your name real quick? Ben. Hey, Ben.
Like science is more studying aspects of like say life in general or just existence, where engineering is the application of said discoveries.
I think you nailed it with the application side, yeah. Anybody want to add to that? Yeah.
Well, I mean, engineering is like a design, like the design.
Absolutely.
Building things.
Right.
Science, you're like studying why those things are, I guess.
Yeah. I think that's absolutely right. Yeah, so you're building stuff. Yeah, in the back. What's your name? Corey. Hey.
So my thought would be science is generally the pursuit of new knowledge, while engineering is the application of the knowledge we've discovered.
I like that. Yeah, so there's something in science that's at the base of it is curiosity driven, right? It's really about how the heck does this work, you know? Maybe, you know, some of you guys, kids are great for this. Do you guys, anybody have kids out there? In the back, nice. That's it? All right, well, kids are cool. You maybe have little brothers and sisters. But kids are always asking questions like, how does this work? What is this? Why is the sky blue? Why are my feet sticking to the floor? That's really what science evolved out of, is an attempt to actually answer those questions in a convincing way such that two people could actually agree on that. So it was it's always been a negotiation, and of course it wasn't called science for most of history. We can kind of like date this project back, in some sense to the Greeks. There was a terrible millennia or so where people in the West really just stopped caring. But it's a search for this mechanism. I'm going to use that word mechanism. Like, I think of it almost like clockwork, right? There's a thing that does a thing that does a thing, and there's a chain of events that lead to the phenomenon appearing the way that it does. It's really this search for the basic question, how is this happening? How is it, why am I sticking to the desk right now? This is insane, right? Like, what is going on? And maybe we can actually answer that question by the end of this course for you. But it's also very possible for me to provide a completely insane answer to the question of why I'm sticking to the desk right now. Like, I could just confuse you even more and pass that off as an explanation. And that happens a lot too. So there's a real battle going on for making sense of reality at all times. And so science is great for that. Now, engineering speaks for itself, right? It's really actually quite a relaxing endeavor. Most people who work in science do a little bit of both. So when I was doing my PhD, half the time I was doing science, half the time I was trying to build these little machines that did this thing. I'll talk about it at some point later. But generally speaking, a lot of scientists have to pay for their work by doing some engineering on the side because practical application. We need gizmos. We need things to make our lives better, right? And so if you were just a scientist, like your entire concern is making sense of reality, you don't get paid very much. That's what I'm trying to get at here, right? It's actually an interesting place. You don't get paid money very much, right? You might get some grants, but honestly, the university's going to take half of it. Students are going to take, whatever employees you hire are going to take most of it. Maybe you have some money left over to buy some gear. Your salary is not going to be much. That's pretty much boxed in. Whereas if you're an engineer, you got a good idea for a product. I mean, this is a great country if you want to be a billionaire. Like, it's possible for the first time in history. You could be nobody and have a cool idea and develop it into a product and absolutely sail to the moon. Like, that's possible. It is not really possible if you're a scientist to make billions of dollars. That doesn't happen. So, again, my question, how do scientists, how are they rewarded?
Knowledge.
I mean, if they're angels, perhaps. Yes, I think that's part of it. How else? Yeah. I love that. I hope that's true. I think it is true for a lot of people, for sure. What else?
Glory.
Glory. Yeah. Achilles. Yeah, it's a glory profession, largely, right? I mean, I can't tell you how many people I went to grad school with who were like, I'm going to get a Nobel Prize, right? It's like, I want to get that big medal to hang around my neck. By the way, how much money do they give you if you win a Nobel Prize? It's like $1 million. It's like nothing, basically. I know a guy. I've met a lot of people who've won Nobel Prizes. Usually they buy like a boat or something. It's not a lot of money, but the glory, right? The sort of like exalted ego that you get from actually solving one of these mysteries and having everybody just agree, like, oh wow, this guy solved it. This lady solved it. Whatever. It's amazing. That's what I see people working for in science. Now, there's nothing wrong with glory on its face. It's a problematic mistress, let's say. It's a difficult thing to chase after because, first of all, there's never enough of it. Second of all, it can actually steer your ship in a weird way. And that's one of the things I think we're going to encounter over and over again. If you really, really want your friends to accept your idea of how something works as being true, that can be kind of dangerous. How do you think it's dangerous? Anybody? Yeah.
Well, if you really want people to think it's true, then you might like like your research maybe wouldn't be as good because you wouldn't want to accept that it's not true.
Yeah, you might not even know you're doing it. You know, it doesn't have to be as simple as somebody just cooking the books on their experiments, although that happens from time to time for sure. A lot of times it's just picking which experiments you're going to do and which ones you're not going to do. I mean, I don't think that most people in the public have any idea how much of a Ouija board running a laboratory is, right? If you have, and you know, most of the time, if you have a really good understanding of something in nature, which you've maybe like just come to through revelation of observing the world and you've come to it, you can design experiments to sort of bring out the best features of that and maybe convince your peers that there's something interesting happening here. But in the worst case scenario, you're so single-minded on proving some point that you kind of miss a lot of what's happening in the weeds. And you get kind of anchored into some position where you're just kind of stuck. I've seen people completely married all the way through their entire lives till they're 80, 90 years old, and in the face of overwhelming evidence to the contrary, there's no space left for them. And so there's no space for them to change their mind, which is really scary. Now, it might be some esoteric topic. It might be something that you might say doesn't really matter. But it's, again, science is really, in its best case scenario, it's a way of learning how to think. And if we can't think clearly as a society, we're kind of screwed, honestly. So this is an interesting conflict of interest. And I think it will be solved. I think your generations will make more sense of this as we go forward. But science inherently, at the moment, in the sense that it's institutionalized, we don't really pay scientists very much in terms of money. They don't have any chance of becoming billionaires. And the only thing they have is basically prizes and the, let's say, admiration of their peers. That presents numerous conflicts of interest at some point, which is really, really interesting. And so there's a whole war going on, basically, and people will say terrible things about each other to undermine their position, not limited to, name-calling and, career Machiavellian antics and stuff. So that's a really, really cool piece of science. So science, it's, I guess we decided it's basically this way of interrogating nature in some sort of systematic, rational manner that allows you to expand your understanding of how things work. And that is a strange profession for someone to go into, barring some angelic motivation to actually pursue an understanding of reality that's actually just grounded in that curiosity. I think a lot of people do start off that way when they're kids. For sure, almost all kids really are curious. I think a lot of scientists get it beaten out of them by the time that they're 40, 50, 60 years old. But it doesn't have to be that way. And there are some really good scientists out there for sure. All right, we already talked about how you guys are going to be graded. Oh yeah, who am I? My name is Dr. DeLay. What do I want to tell you guys about myself? So my PhD was actually in nanoscale elastic mechanics. So I was actually looking at how atoms tug on each other inside of some really extreme confinement issues, which is really esoteric. By the way, what does that word esoteric mean? I've used it like 4 times so far. Yeah. Basically, it's
Level of abstraction.
It's just really niche, right? It's very specific, like expanded body of knowledge. You know, anybody who's like way into Star Wars lore or something, or I don't know, Harry Potter or something, they're gonna know like way too much about some tiny little piece of reality. That's kind of what I mean. And honestly, when you go to a PhD, if any of you do go to PhDs, you will find that you find yourself the world's expert on some piece of minutia that none of your friends want to hear about because you're so deep in something, you're deeper than anyone's ever been in some little aspect of reality.
So it's a nice way of saying nerdy.
Yeah, it's a very nerdy pursuit. Yeah, what's up?
Why did you end up getting a PhD?
It was in biophysics. Yeah. So I did my PhD in New York City at this little university called Columbia out there. It's been in the news a bunch lately. They're getting in a lot of trouble. So that was fun. What else do I want to say about that? Yeah, that's me. Oh, I'm also, so my wife and I actually, my main job is I run this podcast with my wife. It's not just a podcast, it's a little bigger than that actually. It's like, podcast is a huge part of it. So we talk to different philosophers and scientists every week. It's kind of a long form thing. I'll probably put some of those links in if they're relevant. We have talked to people that are studying a lot of the same topics that we're going to be going through, and kind of, well, it's very much like this class. We pit ideas against one another. You have a theory for the formation of Venus, and you have a different theory for the formation of Venus. So we'll talk to each of these people and kind of try to make sense of it. We also put on conferences. We had a really cool cosmology conference in Portugal this summer. It was really, really fun on the beach there, and brought together, again, a lot of people who all disagreed about the nature of where this place came from, or if it even came from anywhere at all. So that was really fun. So yeah, I do that. I also do a ton of music as well, playing a bunch of bands and stuff like that. So that's me. I hope I get to know you guys a little bit better as we go too. All right, let's see here. I think we are about ready to move into our story, really, because this whole course is really, in some sense, a story of how people think about the sky that's above us. And I think a good place to begin would be to really, try to contemplate the night sky for a minute before all of this existed. So before we had neon lights at night. This is Crater Lake. You guys ever been there? Yeah, pretty beautiful place. It's incredible. You can see the Milky Way there. Have you guys, anybody ever seen the Milky Way? Nice, cool. I asked my friends that in the city and stuff. I spent a lot of time in San Francisco. You can't see the Milky Way out there. I can see it from my backyard. I live a bit further north of here. And this is what people saw every single night, though, prior to the industrial age. So, what happens when this is your Netflix and your TikTok and this is what's happening at night, right? You might have a campfire. I'm sure you had a campfire for most of human history. But what happens at night in a small, let's say we're living in some sort of small tribes at some point, maybe villages, depending on where you're at, before cities? What happens? Well, people sit around. Yeah, what do you think? You tell stories. What kind of stories do you tell? Yeah, anything and everything. I mean, to some extent, we still do the same thing, right? It's in different media now, right? For the most part, people read books, people write books, people go to see plays. Do people still go to see plays? I don't know, probably, yeah. We watch Netflix or whatever. We still tell stories. Stories are actually incredibly important. I would go so far as to say the story is the fundamental increment of human knowledge. I don't think that you're really capable of taking anything away from you from this classroom except a story, right? There has to be in order for you to actually imbibe some particle of knowledge, some bundle of information, you have to have a housing for it. You need a frame. And this is something that, as far as I can see, humans have been doing forever. And so back before all of this, people were doing this, no doubt, for sure. And there's a record of that into history. It might come as a surprise to you that history doesn't go back very far, which is really quite troubling. I think history, the record that's actually, let's say, legible, that we can actually make sense of, maybe extends 5,000 to 6,000 years. There's some mysterious stuff before that, maybe some scrawlings and some cave paintings and stuff. But in terms of actually people telling their own stories, we can only read it for a few thousand years. Like I said, anatomically modern human beings that more or less look like you and me have been around for almost 1 million years, from what I can tell. That's a long, long time for people to be making sense of their reality. And they did it through stories. And this was what was happening at night when these stories were going down. And it was probably, in some sense, a much less chaotic world in that you didn't have all of the ills of social media. It was a far less crowded place. But there was other problems too. 6 out of 10 children wouldn't live through adolescence, right? I mean, it was a very rough place. Your teeth are probably going to fall out. There's no dentists. It's a very scary place as well, and you need roadmaps for how to navigate that. So stories obviously play into that. Now, if you're telling a story, like I'm kind of doing with you guys today, I have this nice screen behind me, and I can kind of scroll through here, and I have some visual aid, right? Well, when these people, and by these people, our ancestors for millions of years were telling, let's just bound it. Let's say that humans with language, I'm going to just be conservative and say we've been talking to each other for tens of thousands of years at least, right? Drawing pictures, things like that. But we have this huge projector above our heads every night, right? And so what happens? Well, people start to tell their stories using this magnificent array of light above their head as the illustrations of those stories, right? And so, these are probably what you guys are familiar with as like the standard constellations. What do we got there? We got Leo, we got the Gemini twins, we got Aries over here, Taurus, right? So where do these names come from? These are basically Greek stories that have been mapped onto it. Surprisingly, we still use them to actually identify which region of the sky we're in. So at some point, we'll be talking about like the Orion constellation and the nebula in the Orion constellation. We still use them as maps. But the stories they come back to were invented 2,000 years ago by the Greeks for the most part. And they encoded knowledge. And what's interesting is that on every single piece of this planet, you find people who have told stories about those same groupings of stars, which is really crazy. So there's something in the order of 80, maybe 88 different constellations. People on every corner of the world have been telling stories about those 88 constellations. Now, that might just be a matter of the fact that they're the most obvious stars, clusters of stars, and it turns out a lot of them are actually huge. Some of them contain galaxies. People didn't know that originally. But people have been telling stories, so you can go anywhere you want and you'll get, different stories sometimes. Maybe it's a dragon in your culture. Maybe it's a feathered serpent where it would have been, a bull or something to someone else. But, speaking of the bull, people have seen the bull and the Taurus on different continents that had no communication with each other. They just looked up and they saw a bull and it related to something that was bull-like in their environment, and they used that. So these animals were actually the basis of real events that were happening to people, and they used those real events to tell stories about their own lives and what was important in their lives and the different wisdom that they can encode. So that's pretty profound that people have been doing this for so long, and we still use these same attributes. And you're going to see that as we go through this. As we go through the solar system, the names we have harken back to these really vast mythological substructures. And it seems like the depth to which they penetrate into societies, ancient societies, indicates that these mattered a lot. These stories were really, really, really important to people. And it's not clear that this modern metaphysics has a lot of room for stories like that, which is quite interesting, right? This is the kind of pendulum between religion and rationalism that we were talking about at the beginning, right? So rationalism gives you very nice, clear, mechanistic explanations for things, but it doesn't encode any deeper levels of abstraction to it. In fact, sometimes it just haphazardly results in these abstractions, which can be somewhat unproductive, right? I've pointed out the heat death of the universe as being one of them. But these people didn't. They're actually telling stories of how to succeed in the world, what not to do, what to do. It turns out to be quite difficult. You guys are quite young, but I'm sure being young is really difficult. If it's anything like when I was young, you don't know what's going on. You don't know, who your friends are, who you can trust, what it means to orient yourself to the future, who you want to be. These things are hard to figure out, and a lot of those navigations, the stories of those navigations are encoded in these stars for these people. And this goes so far back. I mean, this is, let me see how old this thing is. This is actually a carving on a piece of bone. I think this one, hold on one second, I thought I wrote the date down. This is from 30,000 BC. So 32,000 years ago, people had actually accurately picked out the places on Orion, the stars in the main Orion. Anybody seen Orion before? Yeah, it's one of the more obvious ones, right? There's 3 in a row and some stuff all around it. We'll talk a lot about Orion in this course. People were obsessed with Orion on all the continents. They were all making up stories around it. And oftentimes what's really profound is that they were telling a story about a hunter in almost every single one of those stories, which is weird on one hand. But on the other hand, it's like, yeah, well, everybody was hunting, and that was probably a bedrock piece of your existence, at least if you were in the compartment of society that was hunting. So, on one hand, it's really strange, but on the other hand, it makes a lot of sense. Again, here's another picture. This is from a cave in France. I think this is from 17,000 BC. And this is an accurate star chart of the Orion constellation with the bull, Taurus, right next to him, right? This is the same story the Greeks were telling 15,000 years later of this bull and this hunter. We'll look at that myth in detail down the road a little bit later. But these stories have staying power. That's pretty freaking crazy. I mean, it's hard to imagine a story that we're still telling 30,000 years later. I mean, most people, you might point to like the Bible or something at this point, but most people can't agree on what the heck the Bible says in any given case today. And it's only been depending on how you chop it up, it's only been 1,000 or 2 years that we've had that text. And it's hard for people to be on the same page about what's even going on. So it's really, really profound that these stories have persisted this long. All right, I forgot to bring this book. I'm going to skip over it. There's a companion piece I'm going to be using for this course, but I did not bring it today, so I'll come back to this next time. So what kind of, besides using the sky as a tapestry, a visual aid, let's say, for your storytelling, why else would you want to pay attention to the sky if you are a person living in a village with 20 to 100 of your closest friends, and you spend a lot of time, every single night you spend with the stars, and you notice things changing? Well, I kind of gave away part of the punchline, but what do you notice by looking at the sky every single night, first of all? Anybody? Yeah. Yeah, things shift, right? I mean, you guys can check this out for yourselves. Like, it's going to be a little different every night. A little bit, maybe I totally recommend, by the way, you get one of those little Starfinder apps for this course, because it's really fun to track what we're talking about. You can actually go out and see a lot of the different planets we're going to be looking at. If you have binoculars, you can actually see some of the moons on Jupiter and stuff, which is really cool. Things change, though, from night to night. That's really interesting. Okay, so you notice things are changing. But what else do you notice? Let's say you watch the sky. Let's say you're more than a year old, or you've been paying attention for more than a year. What do you notice? Yeah.
Well, you might notice that some, just aren't there anymore.
Yeah, so I agree that things will change, and you'll notice that. And that's going to prove important as well. But what else do you notice? You also notice some things don't change, right? You're going to notice there's some interesting rhythms to stuff, right? Like the sun is going to change position in the sky all year long, but then it's going to come back around again, and it's going to do the same thing at some point, right? And why is that important? Yeah, anybody? It measures time. That's crazy. So I'm going to not get into what time is exactly in any, I'm not going to pluck apart the physics of that just yet. So I don't, we'll get there. We want to give it its luxury of detail that it deserves. Time, right? Rhythms. And why would you, obviously they didn't have, they didn't have a clock to tell them what time it was, right? Why do you need to know what time it is, though, honestly? I mean, you don't have any meetings to get to. You don't have any classes to attend. Who cares? Yeah.
Because everything changes on our planet depending on time.
Yeah, but why would you care?
If you're trying to survive, if you're
why would you care for hunting and gathering?
Well, if you're hunting animals, they move based on time.
Absolutely.
The plants change based on the season.
There you go.
Everything is changing, but there are patterns, and those patterns is how recognizing those patterns are how we survive.
Yeah. Anybody have anything to add to that? Yeah. In the back. What's your name? Max. See.
Argue that it's like circadian rhythm.
Yeah. Rhythms. I mean, absolutely. All of your rhythms. There's rhythms are at the core of almost everything, right? Like you just think about it. It's kind of, I don't know if this has ever occurred to any of you, but it's kind of bizarre that you just, pass out at the end of each day and do it all over again the next day. It's weird that we actually experience reality in these rhythmic chunks we just call days. We even have 7 of them for some reason. I don't know why there's 7 of them, and then we start over again. Probably because it would become unmanageable if we had 30 of them that we had to keep track of the names of and which one it was, right? Although that's been tried, like the Mesoamericans, especially the Mayans, did that. What else? What else? Why do you need time? Why do you need to manage these rhythms? You pointed out some reasons. I want to see if anybody else has any more. Yeah.
This is relating to the original question about like what you might notice, but you might notice the moon is tidally locked.
Is tied to.
Tidally locked. Like you'll always see the same face.
You will, but you'll see different phases of it, right?
Yeah.
And that's been really an interesting one too. So the moon changes its phases a little bit every day, and it actually comes back around to the starting points on a monthly basis. And that's a really interesting rhythm too. I'm not sure I want to get into that one exactly right now, but let's say that it corresponds almost exactly to the fertility cycle of women on Earth, which is really quite interesting. So that might be a reason to pay attention to the sky as well if you're trying to clock things. So what else? Maybe, yeah.
Say like communication with others.
Like,
Say you're driving, you're trading.
like I'll meet you at this time. Yeah, like I'll bring the shells, you bring the pelts, whatever. Yeah, the vases of whatever. Yeah. Yeah, keeping track of things. Like, hey, this happened on this day, right? It's crazy how much time matters to human beings, actually. It's actually really, really profound how much our sense of when this happens or this is going to happen really matters. And it mattered, I think, like the low-hanging fruit, which you nailed immediately, are the rhythms of survival. Like the elk are going to migrate every year at this same time. Like they know what they're doing. These birds that fly north and south, they're going to do that. Maybe we can hunt for birds at this time of year. The planting, right? We know when the best time in any given region is to plant, more or less. And yeah, like over thousands of years, the climates change and like these things modulate. But on the year to year, it's like clockwork, these things, right? And so you have to be able to keep track of that. And it seems like a lot of the original astronomical observatories and the systems of noting what's happening in the sky, they in some sense encode those repetitions in such a way that they're useful for knowing when to do what and when it's going to happen. So anybody ever been to Stonehenge before? You should go. It's pretty cool. I heard they were going to build a highway under it soon, so maybe go sooner than later. That's a great example, right? So, and I'm actually we're gonna do a little section on calendars, and we'll talk about the details of how Stonehenge was constructed and what they were actually marking. But needless to say, it marked annual events, and it also marked monthly events very nicely. So there was basically a person who would go around with a stick and place it at different places, depending on where the light was shining through, and the moon, and all of these things, and they would mark basically the days of the month accordingly. So people realized this. They realized the sun's changing position. Now, did they know why the sun was changing position? Not really. I mean, they had stories for why it happened, and in some sense, those stories, we might tear into a couple of them. The stories are pretty cool, and they actually encoded a lot of information about how to behave yourself in society, which would be quite useful to you if you wanted to succeed. But they weren't mechanistic scientific stories. So I'm going to not give away this answer. Does anybody know why the sun changes position? Let's do this.
I'm not explaining.
It's okay. It's okay. Yeah. Yeah. Okay. So how does that work? So why is there less light in the wintertime? Why is the sun lower? In the back, yeah.
We don't spin straight. We spin
Ah.
angle and it propagates
That's right. Yeah, it's actually, well, we do wobble. There might be some wobble, but generally speaking, our planet is tilted on its side. And as it moves around the sun, it's still tilted on its side. So at some points, at least in the northern hemisphere, in the summer, we're leaning into the sun, basically. And in the and then the people in the south, obviously, it's wintertime when it's our summertime. So the people down under, when it's our wintertime, they're going to be leaning into the sun down in the southern hemisphere. So that's really quite interesting. You know, it's a really common misconception that we're closer to the sun just because the orbit around the sun is elliptical, which it is elliptical. But actually, in the northern hemisphere, we're closest to the sun in our elliptical orbit. Sorry, in the winter, we're actually closest in the northern hemisphere. So it's a very, very small difference in terms of the actual distance that the orbit changes. It's not a perfect circle, but it's damn close. So we're leaning into it. And, you know, from a mechanistic basis, this is all well and great, and we will talk about the argumentation that led to people actually concluding this. And they concluded it long, long before they actually had the ability to send satellites into space and actually verify that, yes, this is indeed the case. And there was no shortage of argumentation about it. Of course, people for thousands of years really wanted to believe, at least in the West, that the Earth was actually at the center and the sun was going around us. And that's an interesting story. We'll get to it later. So, I guess I'll add one more point to that. I say the West because there's some interesting, you know, in the West, for most of the history, like down through the Greeks and down into medieval Europe, into the Enlightenment years, people did think that the Earth was at the center of the solar system, the sun went around it. You know, for most of the history prior to, let's say, the Greeks or something, people in the West didn't believe that the Earth was even a ball of anything. What's really interesting is if you look in ancient India at the word for earth, the Sanskrit word for earth, it actually kind of means something like mud ball. And this is a really old word, like 10,000-year-old word, which is really, really weird because I think it's the one place where there's some intuition that people may have understood this long before the rest of us, which is quite fascinating. Unfortunately, the ancient history of India is obscured because no one's actually managed to decode the ancient Indus Valley script, which is totally nuts. There's a number of artifacts that contain a script, and nobody has deciphered them yet. So maybe one of you guys can do that at some point. But yeah, it seems like the Indians may have been alone in understanding that prior to the Greeks doing some heretical stuff that people forgot about for the next 1,500 years. All right, this is another one of these measuring devices. They look at shadows. They look at the position of the sun. This is, let's see, Nabla Playa. This is from Egypt, 5,000 BC, so 7,000 years ago. At some point, people started to get obsessed with trying to rectify the moon with the motion of the sun, which turns out to be a huge, huge problem. You can't actually fit moons evenly into the solar year. So there's not, like if you go off of just a moon, you call that a month, right? Which is reasonable. They both have the same prefix, you know, month, right? So people were thinking about the month in terms of moons, but you can't fit 12 moons into a year. It turns out to be a little bit not, you can fit almost 13, but not quite. So that was a huge problem, and people experimented with all sorts of ways to square the circle of how to fit the moon's position, the phases of the moon onto the solar year. None of them really succeeded, but they tried all sorts of ways. This is one from Scotland, which I think, what year is this from? This is from 8,000 BC, where people are trying to make tick marks for where the different phases of the moon should line up. I'm not sure that they ever actually succeeded. I don't think they succeeded in doing that. It drove them mad. We've talked about enough of these. So there's just tons of examples of people basically mapping these out, trying to find relationships. Now, Sumeria is kind of interesting. About 10 minutes left. Sumeria is kind of interesting. It's the first place where you actually see the creation of a class of people whose entire job it is to make sense of the sky for the first time. So Sumeria is a really interesting piece. Does anybody know where Sumeria was? Cool. So it's basically in modern-day Iraq, right? Which is pretty nuts if you think about it. This place that we just bombed out of existence, basically, was the birthplace of Western civilization, right? And it was the birthplace of modern astronomy, too. This is the first time that you saw a dedicated class of people whose literal jobs was, all they did was measure the sky. Now, what's interesting is that they were, of course, supplying interesting almanac information to the farmers and the hunters and all of that. But a big part of their job was that they were astrologers for the king. So the king would ask them for advice, like, is this a good time for me to wage war against this other, city or something like that? So astrology and astronomy were actually really tightly intermingled at that point in time. Now, the reason why the kings believed that is a little bit beyond me, but that seems to have been a very common practice. The kings would have these kind of metaphysical advisors. This summer, I was in ancient Delphi in Greece. You guys know about the oracle at Delphi, if you guys heard about this, anybody? It's kind of crazy. It's like one of the longest standing religious institutions in the world, where all of these kings would come and ask these like poor girls, these teenage girls had basically been, like locked up in this little temple on top of a mountain, and they were like huffing ethylene gas that came out of the vents in the side of the mountain, and they're just like, gorked out of their mind, and they say some unintelligible stuff, and then these priests basically interpret it for the kings and tell them, again, whether they should wage war or whatever. But this seems to be like a really common practice. People do this, and this was no different for the Sumerians at the time. What's really, really interesting, though, about the Sumerians is just that they really institutionalized it for the first time. So this was a class of people. They were actually called the Chaldeans. They lived in their own part of town. They weren't particularly well respected or well paid, which sounds a lot like modern scientists in some sense. But they did have the keys to the castle when it came to interpreting the stars for the kings. So that's quite interesting. And in Sumeria, actually, I say we trace everything back in the West to that. The West. So this course is sadly going to be lacking in any sort of information about the East. That's primarily because all of the source material is bound behind a language wall for me. I don't speak any languages other than Western languages. It's very hard for me to make sense of Chinese history. I'll try to bring some of it in as much as I can. But a lot of that is really poorly understood, and the Indian civilization seems to have been doing a lot of the same things, but again, the script hasn't been deciphered. Fortunately, with Sumeria, which we can trace a lot of our ideas from ancient Greece all the way into Rome, eventually into the Enlightenment Europe, eventually into America, eventually you're sitting here at a university studying many of the same ideas, perhaps with some refinement. But it all kind of goes back to Sumeria for us here in the West. So we'll be talking a fair amount about the Sumerians because it seems to be really the first time that society gets stratified in this way, where some people have certain jobs that aren't just, growing food or killing enemies, right? There's actually a space set up for people to think for the first time. There's these kind of quasi-academic intellectual institutions that are put in place, which is really quite interesting that people would even have the space, time, or agree to that. All right, we talked about what astronomy means. I'm not going to beat that in. What's the difference between how do I say this? Astronomy, laws for the stars, so patterns, what's going on in the sky. What's interesting is that that's a good starting point, right? But we already talked about how science has to basically tell you how something happens too, right? Now, there's a lot of people, and honestly, maybe you learned this in high school, but science, it is really important to construct, to observe patterns and construct laws that govern how those patterns seem to play out. No doubt about it. But there's a whole other layer superimposed on top of that, which is actually telling how those laws play out the way they do. And I think we're going to find that your textbook in particular often, and a lot of modern science tends to sort of pass over a lot of that stuff. Well, it just happens because it does. And we're not gonna accept that. We're gonna try to actually understand why things happen the way they happen. So laws are a great starting point, but science has to have explanations if it's really gonna do its job. All right. So we've gotten this, astronomy. I want to leave you guys with one last thought for the day. So I'm going to say that astronomy, I'm going to define it this way. It's the study of bodies that lie beyond our planet and the processes by which they interact with one another. Now, that's a pretty straightforward definition of what's going on. I think it expands it a little bit beyond just making laws about the patterns that we see. But there's an interesting word in there that I want you guys to take home with you tonight. The word body. So, in order for us to make this kind of a story about what's happening, we have to understand what this central noun means. What's the difference? What is a body in science? Anybody? Yeah.
A body is like an object of mass that's sort of grouped together as a central thing, or you call it by a certain name.
Yeah, I think you're dancing around the right point. Okay, anybody else? The reason that this matters so much is that I don't think that we can actually say that we've explained anything in astronomy or in physics in general, astronomy being a branch of physics. I don't think that there's any way that we can actually tell a story that has a beginning, middle, and end if we don't fixate on what bodies are doing what inside of that presentation. There's a really, really dangerous and pernicious thing that happens in physics and in science, which has actually become a real problem, which is that people will often start and conclude stories without identifying any bodies that are involved in them. So, what do I mean by body? I mean that every single word that comes out of your mouth is a sound that represents one of two things. It either represents a body or it represents an idea. An idea is a relationship between either other relationships or it's a relationship at its most fundamental scale between bodies. For instance, this is a body. It has a surface, it has inward extension, and it has a location. It's here. It's here now. The most simple relationship imaginable is that I change its location, so it moved. Movement is the most simple relationship in all of physics. But there's no motion without bodies in physics. And we get into some really sticky, weird, supernatural conclusions if we start to try to imagine something like motion without bodies existing. So, can a body, you have a word, let's say unicorn, represents a body. Do unicorns exist? Not really, right? Or maybe that's not a good enough example, because you might say a rhino is kind of a unicorn or something. But maybe a leprechaun, right? So bodies can be imaginary, and bodies can be real. What's the difference between a real body, one that exists, and one that doesn't? Anybody? Yeah.
Well, a real one has a location.
That's it. That's all there is to it. So this axiom is going to be absolutely critical in making sense of everything that comes downstream, and it's going to be really, really critical in taking apart some of the confusions that are really popular today about how things work in the world, because a lot of the explanations that were given, especially in modern mathematical physics, don't concern bodies doing anything, and that's a really problematic place to start an explanation.
Wait, what did you say? I couldn't quite hear it.
Which piece? Good Lord. I suppose that we're going to find out there's a huge problem that's happening in a lot of mathematical physics today, which concerns what philosophers have referred to as the fallacy of reification. It's essentially taking something which isn't a physical body, applying motion to it as if it is a physical body, such as the concept, the idea of mass, or the idea of a force, and moving those things around and calling that an explanation, when in reality, all you've done is started in media res. You don't actually have any actors to provide a physical explanation with. This may seem really esoteric, but it's important on day one that I point this out, because as we start to move through some of the explanations that are given for some of these bodies and the way they behave, what we're going to find is that they terminate irrationally. What do I mean by irrational? What's an irrational number? Yeah.
Can't be expressed as a ratio of whole numbers.
That's right. It's an unending series of digits, essentially, right? A physically irrational explanation is one that doesn't actually terminate in physical actors doing anything. So what I'm trying to say to you is that in physics, if we want to be rational about physics, we have to always be talking about some sort of physical bodies doing something to one another. They might be atoms, they might be actions of some parts of the atoms which are very difficult to lay our fingers on, but at the end of the day, we have to provide those sorts of explanations. Otherwise, we are just moving these abstractions around in a way that doesn't actually ever terminate, which makes it an irrational explanation at the end of the day. This will make a lot of sense soon, but I really want you guys to consider how, as you move through the world, every single thing that flies out of your mouth either represents a body or an idea, and you can't confuse one for the other, or things that are going to stop making sense really quickly. And I think we're going to start to see that there's a lot of pieces of the puzzle that you're going to hear in the pop sci literature and stuff that actually don't make as much sense as they're sold to make on their surface. And that's the point of this class. We're going to be comparing those two different sides of the story. We're going to be seeing where the holes are and seeing all the work that's left to be done. So I hope you guys do stick around. I hope I see you all again on Tuesday. If not, no hard feelings. You have one assignment. You have a couple of things on Moodle. Let me know if you can text me or you can email me. Come see me after class if you're having any trouble with any of that stuff. Otherwise, see you guys Tuesday.